I gave... What's going on, everybody? It's me. I'm back. I had to have blood taken today. I didn't give it to anyone, really. Well, I gave it to the lady that took it, but I wasn't, like, saving lives or anything. I'm actually due to give blood. Put that on your to-do list. What's up, guys? Welcome back. It's Monday. My creativity, done. My urge to continue down this path, fiery and stronger than ever, but I am sucking at it. Yesterday, we did research, but we didn't make a pod. And you know what? We still have to forgive ourselves for it. Should we talk about self-forgiveness? Should we talk about staying motivated? Or should we just shut our mouths and talk about cold shock proteins? Let's do that. See how it goes. What are they? What are you talking about? How do I even begin to understand a cold shock protein? Well, let me tell you something. There's these cool guys in Finland, meaning most of the population, and they sit in a sauna and they beat themselves with little birch branches, and then they jump outside into the gosh darn snow, and they do this on a regular basis. They are incredible. They live a long time. They're big and jolly. They have tons of body fat, and they are healthy as can be. What is going on? Well, let me tell you. They have both heat shock and cold shock proteins being produced. Today, we're talking the latter, cold shock proteins. What do they have to do with autophagy, longevity, lowering inflammation, and just living a better life? Well, a lot. And I'm going to be completely honest here because I have been in a cryo chamber before and I hated it. I hated it. I didn't mind the being of... I didn't mind existing in the cold chamber, but I hated the after. I guess I should also mention I have an autoimmune condition, and I think there might be a pathway issue within me that most people don't have when some of these cold shock proteins are expressed and then what they do to your own genes and pathways. I might have an issue with that. I got big old pink rings around my eyes and I felt like garbage. Most people do not feel this way. They feel phenomenal, like superhumans, and they just have good lives. So do not take my own subjective experience as something that might happen to you. I think you should give it a go. I totally think you should have an immersion tank or take cold showers or run outside butt naked down the street if you live somewhere cold on a very regular basis. I think that would be great. Pretty advantageous as well. I also think that there's some merit to doing the whole cold hot thing together. But today, let's just talk cold shock proteins alone. What are they? Cold shock proteins are small RNA and DNA binding proteins. They are common in almost all organisms. I can't talk today. This is just what it's going to be like. They're common in all organisms, even plants. That means that they're defense mechanisms to some credit or another. Anyways, CSPs, cold shock proteins, as they're known, are characterized by cold shock domains. They are produced when exposed to cold stress. You guessed it. When you're exposed to cold, there's a stressor, right? The cold is a stressor. Like, so chilly, what do I do? Don't put a blanket on. Do not put a hoodie on. Benefit. Your cells are going to start to produce these cold shock proteins that in turn control gene regulation and expression. So what does that mean? We're about to get really technical, and my editing skill and level is not... I guess it's there. Am I too lazy though? I'm probably too lazy. I might put some diagrams on that. You guys, today's the day to grow. We're going to put diagrams on the screen of things like TNF so you can understand what's going on, because I'm about to get real technical and you're about to just zone out and shut the video off. Oh, hey guys, future Naomi here. Editing Naomi here. me here. Bad news. I cut out everything technical because we got real in the weeds, and it's just not, it's not for us. Let me tell you, I explained it very poorly, and we will try again in the heat shock protein episode. But in order to spare you, I cut all of that out so that you didn't have to listen to me talk about it. Okay, let's get back to the episode. Now, stick with me. I'm trying to make this simple. So, before we get all the way there, just hang on tight, buckle up, buttercup. Are you ready? There's benefits to these things. Tons and tons of benefits. They stabilize tumor necrosis factor, TNF. That's a big freaking deal. Okay? They maintain stem cells. They suppress neuronal apoptosis and inflammation. This means they might help fight neuronal diseases, so issues with the nervous system, neurons specifically. They increase norepinephrine. Norepinephrine is used in focus, attention, and mood. They help reduce body inflammation and increase levels of adiponectin. Adiponectin is produced by the fat cells, and it helps blood sugar regulation. This means it's overall phenomenal for your health. There are tons of studies on worms, flies, and bacteria, and not as many on people, but it shows that living at a lower temperature means, in short, a lot longer lifespan. There's even a study with these flies, I think they're fruit flies, and they literally live twice as long as their counterparts when subjected to a colder temperature over their lifespan. This might be due to a slowing in the growth rate factors when exposed to cold. I know this might be boiling it down and being really, really simple, but you know when you put your fruit and veg and your meat and all that stuff in the refrigerator and it stays fresher longer? I think that it's no different when the thing is alive, including us. That's for different reasons, but kind of the same. That's due to oxidation. That's irrelevant here. Okay, cold stuff slows things down. The slower we slow things down, this is why tiny things often live a long time. Like tiny dogs live longer than big dogs. You know what I mean, Jelly Bean? This is part of the reason. Anyways, how do we induce the things? Submerge your body in cold water is usually the main choice, meaning a cold tank. There's really cool videos of people who buy these like gigantic tub freezers and like caulk silicone all over and make it all or watertight and put a filter in there and a regulator, and then it's just freezing right above freezing. It might be freezing, and they just move the water and it gets like a slick of ice on top. They crack that, jump in. You can make one, I think, for $450, or you can buy one for $4,000. It's up to you, dealer's choice. Know what I mean? Little DIY if you're into it. You can also take cold showers. I don't know, depending on your setup, if that actually gets cold enough. I personally don't think my shower gets cold enough because I can just stand in there and it's like, I don't know. But take it for what you may. It needs to be really stinking cold. The other option for this is cryotherapy. I talked about that earlier. You sit in that cryo tank and they blow all this really cold air around you, and you have to wear mittens and gloves and you're butt naked, and then your head is sticking out so as to not breathe in all the cold and like damage your sinus, your inside of your faces. You know what I mean? So it obviously, well, maybe not obviously, it dramatically increases your metabolic rate. We're talking 350% up to, at least. It also increases dopamine. So it's stressing your body out just enough to start to increase and regulate all the things. It makes you skinnier. Let's put this in layman's terms. It makes you skinnier. It makes you happier. It makes you less moody, more focused, and I guess just younger. Who doesn't want that? You know what I mean? Cold shock proteins do not work like heat shock proteins. They activate autophagy in other ways. So heat shock is pretty direct. Cold shock is like this back doorway. Autophagy. What is it, Naomi? You keep saying autophagy. I have no idea what that is. Don't worry, friends. I'm here to help teach you these things. When the body promotes cellular death, of all the old senescent cells. Senescent cells are like little zombie cells. They're not quite dead, they're definitely not alive, and they're not doing us any good. Our senescent cells are usually the cells that like to turn into cancer. For those of you that don't know, cancer in a petri dish is just malformed cells that replicate and replicate and replicate and replicate again and again and again and again. You dig? Cool. So, autophagy gets rid of those things before they can start making problems. Rip out the old zombie cells, make new good baby cells that know how to work and are not damaged. The DNA is not damaged, so it replicates properly. Do you guys know how DNA replicates? It's like a spindle. It unties, and then there's these cool proteins that come in and they cut that ladder in half. It separates, and there's these guys on the ends, telomeres, and they help replicate and copy, and then boop, 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 and you have more cells. It's more complicated than that, but in short, it's like that. Trust me, you're gonna love it if you YouTube it. So to understand cold shock proteins and autophagy, we need to know what a FOXO is. FOXO are transcript factors through the insulin and insulin-like growth factors signaling pathways. They are turned on by hormetic stressors like fasting, cold, heat, and caloric restriction. So essentially, it's this pathway that goes in and helps turn on autophagy to get rid of all the senescent cells, which means we live healthier, better lives for longer, which is a plus. So, okay, we're going to take a little trip back to norepinephrine land. We know that cold exposure increases norepinephrine. We're going to pull a little bit away from exact cold shock proteins and talk more broadly about cold exposure. UCP1 is called uncoupling 1 or uncoupling protein 1. It causes the mitochondria in your fat to be more concentrated and more dense. So more mitochondria in your fat actually makes your fat tissue under a microscope look brown. You may have heard this referred to as brown fat before, and people say, oh, brown fat's better than normal fat. The reason that is because it's highly concentrated in mitochondria, and UCP1 helps that happen. That's a good thing. This helps prepare the body for cold. If you think about Wim Hof, I know we talked about him in the breathing episode, but he's also called the Iceman for a reason. This man runs with like almost butt naked in the mountains where it's freezing cold, and he is in fantastic health. So along that mitochondrial main vein, it also helps increase mitochondria in the muscle tissue, which allows us to exert more energy, and it helps us maintain and hold on to more muscle tissue. This is great. More skeletal muscle means a longer life, you're healthier, and your metabolism is higher because it's more expensive calorically to keep muscle tissue. So to keep it, you have to use it, right? More on that in another episode. You want to be careful though. You don't want to do cold exposure therapy like 60 to 90 minutes after you work out, because there's this like perfect inflammatory window right after you work out, 60 to 90 minutes, that all your body is having an inflammatory response in a good way. It does all the good things to help us build skeletal muscle. We want that. We don't want to blunt that process, right? We don't want to do all this work and then stamp it down. So if you do cold exposure therapy, be sure that you at least wait an hour or two right after exercise. RBM3, that is a cold shock protein. It regenerates the synapses in the brain that are lost during cold exposure. When you expose your body to cold, you are burning some neurons. You know what I mean? They're not like that. So RBM3 comes in and helps repair and rebuild and regenerate all those synapses. And in a mouse study, they found, so the mice were pre-engineered to get Alzheimer's. They found that those who had RBM3, more of it in their brain, and helped regenerate those synapses, it helps stave off the Alzheimer's for mice. They were inevitably going to get it, and obviously people aren't mice, but it did show a lot of hope. So norepinephrine can increase twofold with cold exposure, as we were talking about. Norepinephrine, Naomi, is amazing. So what do we have to do? This is one of the things that makes cold exposure so amazing, aside from cold shock proteins. So how do we induce this response? It's not that bad, right? This is different than producing cold shock proteins, but inducing cold to increase norepinephrine. Studies have shown you just need a cold shower of around 57 degrees for a few minutes, or exposure in cold frigid water of 40 degrees. These are in Fahrenheit, by the way, for 20 seconds. This is great news. It's quick and it's easy, and it helps lower inflammation and pain, and we like that. So if you're out there and you have chronic pain from an arthritic disease or something that's really just painful, you can expose yourself to cold and it's a win. The norepinephrine will double, and hopefully it'll decrease the inflammatory response so that you're not having the pain, but it also helps kind of blunt the pain. Norepinephrine is even injected sometimes to help get rid of pain. That's amazing. Keep in mind, there is one big dog contraindication. If you have high blood pressure, or if you're pregnant, but high blood pressure, it might not be the best idea to induce yourself to cold exposure. That is the end. You have joined me on this lovely journey about cold. I hope that you learned something today. I hope you have a beautiful today. We'll see you tomorrow. And if you liked it, like it. If you have something to say, I'd love to hear it down below. If you don't follow us on the pod, follow us on the podcast. That's where all the good stuff goes. The long, entrenched, really valuable stuff. Everything else comes to YouTube. Subscribe here, though. It's some good stuff. Plus, you get to watch me blab instead of just hear me. It's like a full sensory experience. I hope that you have a good one. We'll see you next time. Bye-bye.